In this review, we'll provide some problems that involve projectile motion. And so let's begin with this one. Here we want to determine the velocity at A and the time needed for the ball to go from A to B. See if you can solve the problem and get the results. Well, first we'll identify the three unknowns. We have the velocity at A, the unknown time of flight, and one more, and that would be the vertical component of velocity of the ball just before it strikes the ground. We'll refer to that as v of b in the y direction. The component of velocity this way is equal to v of a times the cosine of 30 degrees. Anyway, we don't want to involve this unknown in our solution, and so therefore in the vertical direction we'll exclude application of this equation and also this one, because v of y in the equation is really representing this term. The two equations we'll use then is this one and this one. Applying this one, we would say that the final position of the ball in the vertical direction is 0. The initial position in the vertical direction is 0 also. And then we have v of a sine of 30 degrees times the time plus 1/2 of minus 9.81 times the time squared. Two unknowns in this equation. Applying this equation, we have 10 equaling 0 plus v of a cosine of 30 degrees times the time. So we can solve for the time in this equation, get the result here. Of course, to a bit more accuracy, substitute it into this equation and get our unknown v of a, 10.6 meters per second. All right, now try this one. See if you can determine the velocity of the ball when it reaches point B. If its initial velocity is 10 meters per second, launched at an angle of 30 degrees with the horizontal. Well, the three unknowns in this problem would be the time t needed to go from A to B, the elevation of the ball at B, and of course the vertical component of velocity at B. We'll refer to that as v of b in the y direction. Of these three unknowns, we don't want to involve the unknown h in the solution, and therefore we won't use this equation or this one, because after all, y would represent h in the solution here. So the only two equations we have available are this one and, of course, this one. If we begin by applying this equation, we would write v of by is equal to 10 sine of 30 degrees minus 9.81 times the time t. And so here we have two unknowns in the equation. Going down here, we would write 20 equaling 0 plus 10 cosine of 30 degrees times t. And here, of course, we can solve for t. We get the answer at 2.31 seconds. Of course, you should carry out the accuracy here further. Substitute it up into here, and then you can get v of by, which comes out to be minus 17.7 meters per second. The negative sign indicates that the ball is traveling downward rather than going upward. Finally, we can get v of bx by simply taking 10 and multiplying it by the cosine of 30 degrees, because after all, motion in this direction is maintained, and so therefore this component of velocity is simply equal to 86.6 meters per second. So, extending the accuracy of these two numbers and using Pythagorean's theorem, you can get the resultant velocity at B, and it's 19.7 meters per second. And of course, that velocity will be tangent to the path at B. All right, now we come to our final problem. Here, the time needed for the ball to travel from A to B is 2 seconds, and we're asked to find the distance d along the incline that the ball travels, and also the velocity of the ball when it's launched at A. See if you can get the results. Well, we begin by identifying the three unknowns. Obviously, the distance d along the incline is unknown, and so is the velocity at A. And finally, the vertical component of velocity at B is another unknown. I'm assuming it's going downward. We'll refer to that as v of b, y. This component, of course, is related to v of a. Anyway, we don't need to find this component, and so we'll eliminate using this equation and also this one, because that represents v of y in the equations. The only two equations available are this one and, of course, this one. So let me begin by applying this equation. We have d times the sine of 10 degrees equaling 0 plus v of a sine of 30 degrees times 2 seconds plus 1/2 of minus 9.81 times 2 seconds squared. Unfortunately, there's two unknowns in the equation, so now we apply this one. Here we have d times the cosine of 10 degrees equaling 0 plus VA cosine of 30 degrees times 2 seconds. Again, two unknowns in this equation. And so here, I would solve for V of A in terms of D, and I would substitute it up into here and solve for D. And you get the result of 49.7 meters. Of course, to a bit more accuracy. And then you can substitute that value down in here, for example, and you'll be able to get V of A, 28.2 meters per second. Having completed the problem then, we'll end our review.